Hello, this is Mrs. Boots, and we're going to work the practice problems for growth and decay. For each one of these problems, we're going to use our growth and decay equation that has the plus minus in it. Make sure you've got it written down and understand each one of the letters and what they mean and how to use it. Problem 1. Sarah bought 5 fish. Every month, the number of fish doubles. How many fish will Sarah have after 4 months? All right, so what do those mean? Well, 5 fish, that's my A value. Doubles is my R, and 4 months is my T. Did we have the D value in there? Yes, we did. It said every month. Every month means 1. Okay, so now let's plug into our equation what we have. Obviously, we're looking for y. So I have y equals 5 parentheses. Now remember, doubles was a special case. We don't put 1 plus, we just put the 2. And for t, it's to the 4th power. Now you could put 4 divided by 1, but does that change the value? No. Let's compute that in the calculator. We would get 80 fish. Remember, these are things. If it's an animal or a person, you have to truncate it. You cannot use the decimal values. If it's dollars, make sure you take it all the way to the penny. Number 2. A population of 450 animals decreases at an annual rate of 16% per year. Find the number of animals left after 5 years. Well, 5 years is my T. My rate was 16%, so that's 0.16. Make sure you move it the right number of decimal places. How many did we start with? We started with 450. Now remember, this one's decreasing, so we know we're going to subtract. So we should have had an indicator up here. We're going to subtract. We're looking for y. D is what? Per year. So that's every year. Since it's a 1, we can leave it out of the equation. Let's plug everything in. Y equals 450 parenthesis 1 minus. Remember, it's a minus this time. 0.16 raised to the 5th power. Now, if we plug it all in exactly in the calculator, remember, if you don't know how to do 5th power, you just do that little carrot hat symbol, not a big deal. We plug it in the calculator, we get what? 188 animals. Remember, no decimal animals. I don't care if they're pregnant or they only have 3 legs. It's still a whole animal or no animal at all. Number 3. A piece of equipment costs $50,000 new, but depreciates at 15% each succeeding year. Find the value after 10 years. So we're looking for y. Did we get all of our keywords? Depreciates means it's a minus. The 15%, yep, I should have written that as 0.15. 50,000 was our start, and we have 10 years. Okay, let's plug it all in. Y equals 50,000 parenthesis 1 minus 0.15 raised to the 10th power. Okay, plug it in the calculator, and we get, remember it's dollars, $9,843.72. Ouch. In 10 years, from $50,000 to less than $10,000. That's gotta hurt. Number 4. On the day you were born, Uncle Peyton gave your parents a piece of sports memorabilia, valued at $75. If past trends should hold, it would appreciate positive 12% per year. So it's 12% written as a decimal, 0.12, per year. If you sell it on your 18th birthday, so we have 18 years, they want to know what the value would be. Let's plug it in. Y equals 75, parenthesis, 1 plus, because it's appreciating, 0.12 raised to the 18th power. Wow, maybe it'll be a big number. Okay, let's see. Plug it all in. It's worth $576.75. Not bad, but I'd keep it a few more years and let it gain more value. Number 5. A general rule of thumb for used car dealers is that the trade-in value of the car decreases by 30% each year. Wow, that hurts. 30%, 0.30. How much will a $25,000 car be worth in 6 years? So I'm starting with $25,000 car and 6 years later. And I forgot that was each year. We're looking for the final value. So let's plug it in. Y equals 25,000, parenthesis, 1 what? Minus 0.30 raised to the 6th power. Something tells me it's not going to be worth much. Yep. $2,941.23. Now, if you actually go to a car dealer, most of you would realize that usually they'll give you $3,000 as a minimum trade-in, $2,000 to $3,000, because that's how much you could sell it for to a scrap yard or a junk dealer who's going to strip it down and sell the parts individually. Number 6. Cobalt 60 has a half-life of 5 years. Well, half-life is my rate, and it's about 5 years. So that's actually my D value. We have a problem where D is not 1. How much of an 8-gram sample will remain after 30 years? So I'm starting with 8 grams, and we're going for 30 years. Okay, want to know how much is left. Let's plug it in. Oh, do we plus or minus? Yeah, we're going to minus. But remember, half-life's a special case, right? Because 1 minus half, we can just write half. So I have 8 parenthesis 0.5 raised to the 30. Well, remember, you got to divide, right? 30 divided by 5. Don't forget the 5. Okay. Now, how would we plug that in the calculator? Remember, you can enter all of this. This whole thing, 30 divided by 5 is what? That's 6. Okay, so let's rewrite the equation a little simpler. That's 8 parentheses 0.5 to the 6th power. We can plug that in easy. Well, how much is going to be left? 0.125 grams. So not even a whole gram, but it's 30 years later. So there's probably a different scientist working on it by now. Number 7. Radioactive carbon-14 has a half-life of 5,730 years. Again, we're dealing with that good old half-life. So we know it's a 0.5 and we're subtracting. And D is 5,730 years. Wow. How much of a 100-gram sample will remain after 11,460 years. Now, yes, you're not going to be around, and neither am I, because we'll both be dead by then. However, scientists use this in what's called carbon dating to figure out how old things are that we find, fossils, clay, pottery, other things, so that we can estimate its age and figure out how long it's actually been there, who could have made it or done it. All right, so let's plug it in. So we got y equals what? 100, parenthesis 0.5, raised to the, 11460 divided by 5730. If you're not sure, you can always put your exponent in parentheses. Okay? It's not a big deal. So we got y equals. Plug that into the calculator and we get 25 grams. So this is what they do when they're doing carbon dating. They see how much they have and they know the decay rate for that particular carbon isotope. And so they will figure out how old the object is based on the amount of carbon left in it. Number 8. If the U.S. population was about 226 million in 1980 and is growing at a rate of 1.1% per year, so I have 1.1% every year, what will the population be in 2010? So I'm starting with 226 million. Please don't put all the zeros, just 226. That's in 1980. So how many years are between 1980 and 2010? Well, that would be 30 years. Obviously, this is an old problem because last time I checked, we've passed 2010. But that's okay. So, let's plug it in and see if the model gives it correct. So y equals, we put our 226. Again, do not put all the zeros. We'll just get our answer in terms of millions. Remember, you have to move the decimal 2 places. So I would have 1 plus 0.011, and that's raised to the 30th power. Wow. Okay. Y equals 313.79 million people. Okay? So because we're dealing with millions, the 0.79 is an indicator you can move the decimal, and that's part of your value. This concludes all of the practice problems for growth and decay.